So yes, the third session, and we're still in part one with physics. I'll do a quick recap of what we've covered so far, and then we will wrap up with some final comments about the key things that we're taking away from physics. And then we'll go into part two today and go into the biology side of things, okay? As usual, please use the chat if you'd like to ask questions directly to me as well, but always like to have people just put up their hand and ask questions too. Either way is good. With that, maybe I'll go into just a quick recap of what we've talked about so far. So the key takeaways that we have from a study of physics that then feeds into philosophy and any discussion about God, it starts with a clear picture that physics is giving us, that the universe is very ordered. There is a very strong overarching order and consistency in the way that it behaves. And we summarize that through these laws of physics that we have discovered over the last 500 years that do an amazingly good job of predicting what behavior we will see from nature, testing it with experimental evidence to confirm our understanding, okay? And so this is a very important overall conclusion that is really not going to change over time. One of the key things that I want to send as a very important piece of advice for us all is really not to rely too much on any one particular theory to form our conclusions, okay? Because the theories will change, our understanding of physics will change over time. If our philosophical position depends on some particular theory and it changes, then we get into trouble, right? So that's why we really just want to take generalized conclusions from a study of physics rather than too much of a focus on any specific theory, okay? This is really, really important. And then I wanted to clarify a couple of things from last time. One is that when it comes to the fine-tuning, remember we found that it turns out that these laws are not just beautifully mathematical in nature, but they're also very, very fine-tuned to give a universe like the one we have. Otherwise, we would have, you know, an empty universe or a universe only full of neutrons where you can't even build structures with it. It would be a completely different place and life would not even be possible. Those numbers that I showed about the degree of fine-tuning, you can think of those as just how precisely those laws have to be exactly the way they are. They're not really probabilities, right? We talked about probability a little bit in the question and answer session, but those are not really probabilities. Those are mostly about just how specific do these constants of the laws of physics have to be, or the initial conditions to give rise to them, okay? So it's about degree of fine-tuning rather than probability. And then the other point was around the Big Bang. So the Big Bang, we said, it's this theory about how if we rewind the clock, it looks like the universe started with a Big Bang, an explosion, where all of space and time and matter and energy all came into being at the same time. Now, I still call it a theory because it's not entirely clear the details. Right at the moment of the Big Bang, our laws of physics kind of break down because everything becomes infinite, actually. And so things break down. And so there are different interpretations of what happens in that moment. Is it actually the beginning of the universe, or is it that time takes on a different meaning? And there's different theories around that, which is why I haven't focused too much on it. One particular theory around it is called inflation. Not inflation like we have in the economy, but inflation is a physics theory of how the universe began at the beginning, the very early stages, right at the beginning of the Big Bang. And it's not really that well accepted yet. It's been around for more than 40 years. It's had a lot of criticism to it. And so I haven't gone into these type of areas, but there are some who dispute whether there was a beginning or not. Okay, even though there was an explosion, this Big Bang, when you rewind the clock to time 0, what happens, and then what was there before that, is a bit fuzzy. So that's why I don't pay too much attention. And very importantly, I don't think it makes a big difference to the discussion about the existence of God. We should not rely on a theory that says the universe definitely had a beginning. Okay, I always want to eliminate any weaknesses in our arguments. So we don't rely on any particular theory, and we don't rely on the fact the universe had a beginning or it didn't have a beginning. These things are not what really matters. Okay, so just a couple of clarifications about some questions that have come up and some more detail around the things that we talked about. Okay. All right, with that, let's go to today's material. And it's really wrapping up, what is the overall picture that we are getting from physics? And what I would say is that physics has really been on a path of unification for the last 300 plus years. What we found is that initially we came up with a whole bunch of different laws of physics. Oh, if you're looking at this particular type of a system, it has its laws. If you're looking at a different type of system, it has its laws. And then we kind of started to understand how they're all connected together. Okay. And we went from a whole bunch of different laws to a situation where, if I share my slides in a second, hold on. Can you all see my slides okay?
Yes, it's okay, Hani.
Okay, great. So this is just summarizing what I'm saying. Initially, we had a whole bunch of different systems and laws that we tried to figure out. Then we basically narrowed it down to 4 fundamental forces that summarize everything that we see happening in the universe. Okay, 4 fundamental forces. Those are gravity, electromagnetism, and then the weak and the strong nuclear force. Just 4 forces acting in different ways that basically we can use to explain everything that goes on in the universe at a physical level. Okay, but then even that, what we started to do was see, okay, but these 4, how are they interconnected? And we began to see that actually electromagnetism, the weak nuclear force, and the strong nuclear force were actually shown to be aspects of one single force, actually, one quantum field, which I started to talk about last time. These were actually only different aspects of one particular force. Okay, so this was called the grand unified theory. And what it showed was, as you go deeper into how these things are behaving and interacting, you'll find actually, no, you can actually explain it in a more simple way, a more unified way. And that left us with only 2 forces, okay? The gravitational force or field, and then the quantum field, just 2. And I talked about those before, but you see how we started with 4, down to 2, and now all of the work is on trying to unify these 2, gravity and quantum, into a single unified force called the theory of everything. Okay, so it's a path towards unifying, seeing that everything is actually interconnected and one single field of forces and particles can explain everything that we do, which is truly amazing to think about, that there's a way for us to actually integrate everything we see into one single framework. It's quite amazing. And there are different candidates right now. This is still a work in progress. It's proving to be quite difficult. We made very quick progress to get down to 2, but since then it's become very difficult to try and find a way to combine these 2. There are a couple of different theories that are currently being worked on as candidates. One is string theory. I think in the chat we had people who are talking about that. String theory, or a class of string theory, is called M theory, is one way to try to think about how to combine these. And it's an interesting one because basically it says, you know, we were always taught in school that, oh, can everyone go on mute, please? Especially when you join. We were always taught in school to think of these little particles as like almost like small little balls, right? An electron was like a tiny little ball moving around a nucleus, which was another kind of tiny little ball. In string theory, we actually postulate the idea that what the ultimate building blocks are strings, actually. Strings rather than tiny little balls. Okay, and then what we understand is the idea is what makes one type of particle different from another type of particle is not what it's made of. They're all made of the same strings. It's just how those strings vibrate that makes them a particular type of particle. It's so interesting to say it's the same string, but you have one type of frequency of vibration, and that is an electron. If it vibrates in a different way, that is a quark or a boson or some other kind of fundamental particle, but all made of the same fundamental strings. Okay, so that's one approach. It has not been proven yet. It's a work in progress. It's an interesting idea. We shouldn't focus too much on it. Overall, though, it's likely that we're moving in this direction of unifying into a single framework. Okay, so with that, I think I'll stop on physics, and we can take questions at the end when we get into the Q&A session. All of the topics that we've covered in the sections up to now are open for questions when we get into the Q&A. But for now, we'll just leave physics at this point with these big conclusions about the order that we have, the mathematical structure of these laws, and the fine-tuning that we see, and the unified framework that comes out of it. It's absolutely beautiful. All right, with that, we go to biology. Now, before we dive into that, I want to say that my background is much more about physics. I know the physics stuff inside out. It's my field, and I'm very confident in all of the details, and anything that comes out of that, I'm happy to take questions on. Biology is not my area of focus, so I'm here sharing much more what others have put forward, and I'll share what the issues are, what the different viewpoints are, but it's not really my area of expertise. Okay, so I want to just mention that right from the beginning. All right, so what is it all about when it comes to the biology side of things? Well, the big picture is that essentially what we have learned from biology over the last several hundred years is that, of course, we know DNA is really at the heart of what life is and how it works. DNA being a very specific kind of a molecule, which has this kind of double helix structure, this coiled structure. I'm sure everyone has seen. And basically, DNA contains all of the instructions that are used by the body, by every single cell in the body, to replicate itself and to function. All of these instructions are sitting in the sequence of the molecules, of the bases in the DNA molecule itself, okay? And the big question is really, this is essentially like a computer program. It's like a computer program. And the question is, where did the program come from? How did this information that's contained in it, where did it arise from? How did it come about? Okay. Now, I'm going to start by playing just a couple of short videos just to kind of bring this to life, because if I just talk about it, it doesn't really have the impact of compared to when you see it for yourself. And I'm sure a lot of you have already seen these, but it's still good I never get bored of looking at these videos, because it's just stunning that all of this is happening within us, within our bodies, every single moment, in every single cell, and every single moment, day and night. It's always good to stay amazed by what we see there, okay? Now, this is taken from a guy called Stephen Meyer. He has done a lot of work on this question about what is the origin of the information. And he is someone who puts forward that there is intelligent design being shown here. You can see that there must have been an intelligent designer who made this information, okay? And he has a really good book on it as well. I'll talk about the books in a moment, but this first animation actually comes from him, and I will just try to share that now. And hopefully everybody can see my screen, and away we go.
In 1957, Francis Crick first proposed that chemicals called bases along the spine of the DNA molecule function as alphabetic characters in a written language or digital characters in a machine code. This animation shows how this digital information directs protein synthesis. First, a large protein complex separates the tightly wound strands of the DNA to prepare it to be copied. During this process of transcription, a protein complex called a polymerase produces a single-stranded copy of the original instructions. Here we see this copy, a messenger RNA molecule, being constructed inside the polymerase as individual bases are positioned and added to the growing strand. Now we see the polymerase in action from the outside as it spits out the messenger RNA transcript. Next, this RNA transcript approaches and passes through a molecular machine called the nuclear pore complex, an information recognition device that controls the flow of information in and out of the cell's nucleus. Now we see the genetic assembly instructions on the messenger RNA approaching and arriving at a two-part chemical factory called a ribosome, the site of protein synthesis. As the messenger RNA transcript passes through the ribosome, the process of translation begins. During translation, a mechanical assembly line builds a specifically sequenced chain of amino acids in accord with the instructions on the transcript. These amino acids are transported from other parts of the cell by molecules called transfer RNAs, which link specific sequences of bases to corresponding amino acids. The sequential arrangement of the amino acids determines the type of protein constructed. When the construction of the chain is complete, it is transported to a barrel-shaped machine that helps fold it into the precise shape required to perform its function. After the chain is folded into a protein, it is released into the outer cytoplasm to do its job in the cell.
Okay, hopefully you could hear all of that part clearly. I'll play the second one. Now that was showing how the DNA works, right? This way that it gets copied by having this RNA messenger kind of produce transcripts that then moves to other areas of the cell and so on. This video now will just show a wider view of just different structures within the cell, okay? This is called the inner life of the cell. Let me just play this one as well. Can I just check in? You guys hear me okay? You can see my screen? Yes?
Yeah, yes, Hani, it's okay.
Oh, right. Okay. Just checking. Thanks. All right. Enjoy this. So try and get this off my screen. Okay, so hopefully you're as mesmerized as I was. I can't never get bored of watching those, but hopefully it gets a feeling for you of just the level of complexity of involved in the functioning of life. Okay, and all of that, everything you saw, all those, and this is just a short version. I'll maybe send you guys longer versions of different parts of the cell and how they function. It's just unbelievable, the level of complexity of all these different processes that are happening. And it's all programmed in the DNA. The whole thing is really centered on DNA, which has all of the instructions to make all of those processes work. Okay, and the question then just becomes, well, that's like a big program of instructions. It's like a computer algorithm. Follow these instructions, and this is how you make life. So then, where did this program come from? Where is the program? How did this information come about? Okay, that's where the big discussion is. Now, in today's science, we have not figured any of this out, really. Some experiments have been done for a long time to try and understand how this all comes together. We are very, very far from seeing how any of this has actually happened. All we've managed to do is make some tiny little building blocks here and there. But to build this entire structure, we're very, very far from explaining that. I want to give you a sense of just the amount of information that we're talking about here. So let me just put up a slide for you. I think some of you know this guy, Mr. Bill Gates from Microsoft. He has a great quote, you know, because he's Mr. Computer Program, right? One of the earlier programmers that developing Microsoft as a company that none of us can live without these days. And he says, you know, DNA is like a computer program, but far, far more advanced than any software that we've ever created. Okay, and the way it works is really interesting. DNA basically has 4 letters. Okay, just think of them as 4 letters with which you can write sentences, right? It's A, C, G, and T are the abbreviations of the letters. And now I'll just give you an idea of the scale of what we're talking about. So DNA in each human cell has 3.5 billion of these nucleotide bases, right? These bases with these letters. 3.5 billion, okay? And then each cell contains 2 meters of DNA, okay? Just think about it. A tall man it barely reaches 2 meters long, right? And there's 2 meters of DNA curled up in every human cell. And there's 75 trillion cells in your body today, right? If you took all of that DNA, it's an amazing statistic. If you took all the DNA in your body and you stretched it out, it would stretch to the sun and back 100 times. Okay? Just to give you an idea of how much is being compressed in there. And the density of it is equivalent to putting all of the libraries in all the languages in the world into a volume 1% of the head of a pin. So very condensed. It's like a super zip file for your that compresses your data files. Okay. So how much in one single cell? It's 1.5 gigabytes of data is in there, right? GB, 1.5 GB of data is being contained in a single cell. So, you know, the big question becomes, well, did this just come together randomly, you know, by chance? What's the probability of that happening, right? And the answer to that question, it's been looked at in detail by this guy, Stephen Meyer. And if I just share, oh, can you enable me for sharing, Johnson? Okay. So I assume you can see my screen again. Yes. Right. So yeah, the DNA itself, I mean, it's almost too much to think that this all came together randomly. So we even just look at a single average length protein. Okay, proteins are the building blocks of life. If you just take a single average length protein made of 150 amino acids, okay, the chance of that coming together randomly is 1 in 10 to the 37, right? So 10 with 1 with 37 zeros in it, just to make a single protein. And you need thousands of these different types of proteins. So, you know, even if you had the entire universe working on this, okay, and running different, you know, random interactions every single second, you wouldn't even have time to create 500 letters of code, right? Even 2,000 bytes of information, let alone 1.5 gigabytes of information. So in fact, the research in this area basically shows, okay, it did not happen randomly. It did not happen by chance. So there must be some kind of intermediate steps, some kind of mechanisms that try to, you know, explain how it happened gradually. And there's really kind of a few different views on all of this. So let me just put those out, and then we can discuss. On one hand, there's a view that says, look, this could not happen by itself. It needs intelligent, an intelligent agent intervening to make these things come together. Because what you see is information, and information, everywhere we see information, we see it as the result of the actions of an intelligent agent. That's everything that we see in our experience shows that. And so the conclusion is you must have had an intelligent agent that actually was intervening to bring these things put these molecules in the right sequence. Because it's not just putting a big sequence of letters together. You have to get the sequence right. The order matters more than anything else, right? You can have the letters there, but you have to create these sentences and paragraphs and books, because there's literally books and books worth of information. And so that's one view, is that there's an intervention. And, you know, people have even thought about maybe intelligent agent doesn't mean God necessarily. Maybe it's an alien. Maybe this is an earlier alien civilization from a different part of the universe actually came and did this, right? So to that point, that, you know, you need intelligence to explain all of this. That's one viewpoint. And essentially, it's a kind of intervention, right? If you need an agent that's come in directly and is manipulating these things to create the secret. That's one approach. The second approach says that no, we don't need to do that, and we should usually kind of avoid trying to explain things that way. Okay, this is how a lot of people who do believe in God get into trouble. In the past, they've always got into trouble by this. We kind of discussed this a little bit last time. You know, there's some kind of process we don't understand, and we say, oh, this couldn't have just, you know, there's no way to explain this. God did it. God intervenes and makes this happen. And then we start to explain, oh, no, here's the mechanism. This is how it can happen. And then there's no room left for God in that particular process, right? So they call this the God of the gaps, right? Wherever we have a gap in our knowledge, we say, oh, God did it. And I personally don't like that approach altogether. I think it's much more interesting and much more likely and much more safe in a way to think about it as that there's a system, a structure that God has designed, or the intelligence has designed, and that allows for these things to emerge naturally through the working of the system by itself without needing any kind of artificial kind of intervention randomly here and there from an external source. Now, one thing though, with this particular case, when it comes to life, it's hard to see. I have to admit, it is really hard. How are we going to explain this? Because the sheer amount of information we're talking about it's quite daunting to think that there's some kind of a mechanism that allows it to happen. So my attitude to this overall, personally, is to think of it as bring it back, and maybe this is because I'm a physicist, and and that's my kind of background, is bring it back to the laws again. Okay, so let's say that this kind of emergence of sophisticated levels of information that enables all of those activities that we saw, all of that is being enabled by those same mathematical equations that have been there from the beginning and have not changed. You see, it's an even more amazing achievement in a way, is that you can have these very simple, beautiful, elegant mathematical laws that have just been there in the background from the beginning and enables all of this to happen, right? Naturally, just for it to, through its own workings, just those laws alone can do it. That makes the laws even more special, even more amazing than what we were talking about before. Because if they were even slightly different, none of this information would have even been possible, right? There would be no molecules. There would be no atoms, right? If one of those fine-tuning parameters was off, sorry, there would be nothing actually physical in the universe. It would be empty, for example, okay? So no life, no possibility of life. The fact that they work in the way they do and the way they're balanced together, that would even allow this kind of information to arise naturally, would be even more stunning, to be honest. It doesn't need someone to come around and poke around with the molecules and artificially create that information, okay? So it's a different approach. I'll be interested in what you guys think, but these are two ways in which it's being discussed. Yeah, so that's one of the key things I wanted to share was on the DNA itself, the amount of information that's contained in it. There's one other aspect of this that I wanted to also share, and I'll put that on the screen now. And that is, okay, what happens after that? When you look at how life then, that we were just talking about the DNA and then, single cells. How did then the complexity of different life forms develop from there? And what we've seen is that when you look at the fossil record, right, you look at different types of rocks and how different life forms came into existence, and you can see what this is like a timeline on this diagram here. As time goes by, you get more and more different types of living beings coming into being for the first time. And one really interesting thing that happens is that there's a period of time in history, it's called the Cambrian era, okay, which is around 530 million years ago. When we do experiments on the rocks, we can date the rocks to around this period. What happens is you suddenly see an explosion of different types of life suddenly comes into being, okay? It's sometimes called the biological Big Bang, all right? All kinds of different creatures with different organs and tissues and cell types. And it all happens suddenly. So if you see it on this chart on the right, you get a sense of, this is moving up here, upwards, you're moving in time. And this is giving you a number of different life forms. So the wider this goes, the more life forms you get. And it's a sudden explosion of these happening. That's several million years, but in geological terms, it's very, very fast that you suddenly get huge number of these different types of living organisms suddenly, almost in the blink of an eye, effectively. And the way to think about this is that just like the DNA itself contains information, when you create a new type of life, okay, so you go from a fish to something that can walk on land, you need different types of organs, you need legs, you need arms, or whatever. How do you make those, right? How do you make a new body part? You need more information, right? You need more instructions to create these new parts of the body and everything that connects them together and everything. So this explosion of different types of life is essentially like another explosion in growth of information that's contained in the DNA of these living organisms. And the same question arises: where is this information suddenly coming from, right? Now, the overall scientific theory that is followed in the world today is Darwin's theory of evolution. I'm not going to talk too much about that in detail, but on this particular issue, it has a problem, because it's thought that evolution works through a very gradual process of tiny, small little changes leading to big changes over time through survival of the fittest. But I'm pointing out this Cambrian, it's called the Cambrian explosion, actually, because you get this explosion of different living forms. This is the opposite of what evolution would say should happen, right? It's the opposite. Evolution would say all this variety can happen, but it needs a lot of time, and you'll see it happening very gradually over time. That's what you would expect to see. Instead, what happens is you get this massive jump of evolution happening, different life forms happening, all this new information in the DNA, and it happens very quickly. And they don't have an explanation for it right now. So these are all just kind of things that we should be aware of about how biology works and what the implications potentially are for any discussion about the origin of the universe and the source of our existence, because all of this is very intimate for us. This is not just about the universe and stars and galaxies. This is about life now. Where did life come from? How do we explain life? And so these are two kind of dimensions of it, but it's all related to this, the creation of information. What is the origin of information itself? Like I said, for now, science is working on this, trying to explain, the origin of life itself, right? That was the first part. Remember, this is the actual origin of life itself, going from non-living to living. That was what DNA was about, and looking at the probabilities of that. And essentially, it's impossible that it was entirely random. And then the second part, when we're looking at the fossil record, it's about how life has evolved over time. And again, we see this explosion of information content in the DNA. And the question is, again, where did all of this arise from? And so, yeah, I will maybe stop there. As I said, I have a lot less to talk about when it comes to biology. But what I know from reading all of these materials on this particular issue, that's what it really boils down to. You have to be able to ask this. These are the questions that are being asked. What is the origin of the digital information in DNA? Can this arise randomly, or how do we explain how it comes? And then there's different viewpoints. The naturalistic people who say just literally, it was just random, or there's some way in which self-replicating life forms come about. And that's really where the debate is. And I'll stop with just my personal view of this. And all of this, remember, we're going to take it into part 3, where we go into the actual philosophy and debating different explanations for these. Is that, to me, what is very clear, and the reason why a lot of research is being done in this area is because to say it just happened by chance is really not a credible answer. Nobody really believes that. Okay, like literally randomness, chance happened. It doesn't make sense as an explanation. It's like coming across an entire book or literally a library of books by accident. Say, yeah, these pages and these letters all came together by chance. Nobody believes that. Okay, but then there's a lot of work being done to see, okay, how can we understand this really incrementally? Small little building blocks that could have come together, and mechanisms to create this information. And I think there's chances that we will get there. And I'd be very, very careful to discount that we will come up with an explanation, scientific, for how this happened naturally through different types of chemicals under different types of conditions, maybe in oceans, maybe in very hot springs, all kinds of different ways in which we can have these interactions happen that gives rise to this stuff. But even if it does, the end result is so astounding that it just draws attention for me back to the underlying fabric of the entire universe, which is the laws that enable all of this to happen. It just makes it even more of an unrealistic view to just say, oh, these laws have always just been there. You just have to accept that the laws have been there and that there's no source behind them. There's no mind behind them. For me, that all points to mind. And as I said, the mechanism doesn't really matter. The fact that it's here and that it's kind of built into the laws itself, right, that allows it to arise without any intervention, it makes no difference to the arguments that we'll go into in more detail. All right, with that, I think I'll stop there for today, and I hope we can have a good discussion about all of this. Thank you.